Hi, I want to talk to you a little bit about the proof by contradiction. So this is on page 2 of your textbook. I've uploaded 2 videos on example 3 and 4. So the proof for root 2 being irrational and there being infinitely many primes. They're both quite famous proofs, so if you have a look on the internet there's loads more information on those. Example 1 is fairly straightforward, so hopefully you can just understand that by reading through. But example 2 is slightly more tricky, and the thing that I think is difficult is finding this assumption here. So you're asked to prove that if n squared is even, then n must be even. So it's not necessarily saying that n is even means n squared is even. It could be that for some numbers you get an n squared being odd. The implication is going this way. This is true, therefore this is true. And then you've got to try and think about what the opposite is. Well, if this is true, that if n squared is even, then n must be even, then what I can say is that it is never the case that this is true, n squared is even, and n is odd. You see? So if this is true, that for n squared being even, then n must also be even, then it means that we never have an n squared even when n is odd. And so my contradictory assumption here is going to be n squared is even, n is odd. So this statement here remains the same. That's always the case. This statement on the left remains the same. Your implication goes round the other way. So I'm trying to find this case. I want an n squared odd where I want an n odd where n squared is even. And then this statement is reversed and becomes the opposite. So change this statement, change your last statement, and then flip your implication. So you can either think it through logically, like this. Never the case that n squared is even, n is odd. So if I find even one n odd that gives me an n squared even, then it means that this can't have been true. Or you can just remember to keep this the same and flip your implication round. And then after that it's not so hard. So now my implies have started the other way. I'm going to start off here. So n, we can call that 2k plus 1 or minus 1. Make sure you use a different variable here, so don't use n again. And so this is my n. N is an odd number. And then we square it. And then here you get eventually to 2k squared plus 2k plus 1. So I've skipped out a little bit of algebra there. Make sure you factorise out 2 here. So if you notice you could have taken 4 out sides. You're kind of showing it's a multiple of 4 then. I don't think you'd lose marks if you do that, because obviously a multiple of 4 is a multiple of 2 and it should be something that's almost assumed, but it is nicer to take the 2 out here. So then you're showing that this thing here is an integer. And so therefore this whole thing here must be an even number, and then when I add 1 I get odd. And then the more you kind of like write here to sort of explain that process, the better. And then you always want to finish off with a statement. So you want to say, because I found a contradiction, this must not be true. And so because if n is odd, n squared, it contradicts this assumption that n squared is even. Therefore, if n squared is even, this number must be even and not odd. Okay, let me know if you need any more examples. I wouldn't be surprised if you're working through that exercise you get stuck in some places, because it is a little bit tricky. And I can always do some more videos for you. Okay, thanks everyone.